So today we're doing activity diagrams and class diagrams. What is an activity diagram? Wait, I didn't have this picture in the back. What is an activity diagram? When we learned the use case diagrams, we said that each use case is a functional requirement. Right? It does something for the system. So an activity diagram shows the sequence of actions that the system performs in order to realize a use case. Therefore, an activity diagrams are very closely related to use case diagrams because they also show like what the system does. And I'm going to just jump ahead and show you an example of a use case diagram. Here, for example, this very simple one. This is an activity diagram. User enters a name. Then you come to a triangle, or not a triangle, a diamond. And you could say, for example, let's say you're trying to determine, he wants to create a new account. So if somebody already has that name, you can't give it to him because somebody else is using it. So we say, if it's not available, we go back and he enters it. Is it this? And if it is available, then we go to here. So we use a diamond to indicate an if, essentially. If it's available, then if we write on this line what it means. And we write on this line what it means. And then he enters a password. And if the password is sufficiently complex, then we confirm his account and we go to this circle like this, which means the end. And we're done. And if the password was not sufficiently complex, then we go back up and ask him to enter a password again. The truth is, this is very similar to something called a flowchart, which I learned when I first learned computer programming, let's say in high school. For several months before they taught us any language, they taught us just to solve problems with a diagram like this, because it shows you looping. You can do a loop like this, if counter is reached 10, then then don't go back, but otherwise go back. You have this whole, you basically can write a whole program in this in these diagrams. And that's what you're going to have to do actually for parts of your program, parts of your thing. You're not going to actually program it, but you're going to write some kind of diagram of checking what your ifs are. So you need, so the diamond is for the if, and this capsule looks like kind of like a pill, like a I don't know what you call that, headache pill within a capsule. That's the shape, and that's called a process. Something you're doing. Like entering, like doing a C in or a C out is a process, or adding two numbers together and getting a result is a process. Sometimes the computer does, but doesn't, not as opposed to an if is not a process. An if, you're not processing anything, you're checking something. There's basically everything a computer does is either processing some data or checking, right? If you think about your days of computer architecture, either doing like an add, or a subtract, or a multiply, or you're doing a branch, right? You're doing some kind, or print, but a branch is the diamond shape. That's the basic thing. Now, we have a whole lot of slides before that that basically just say that there's different kinds of structural diagram, behavioral diagram, and interaction diagram. We actually, before we divided up diagrams a slightly different way. We said there were static diagrams and dynamic diagrams. And what we're calling structural diagrams here is what we called static was before. And what we call dynamic, we're calling now two different kinds of dynamic, behavior and interaction. And we're actually going to learn these we learned the use case, and we're going to learn the activity diagram. We're also probably going to, I think we're going to learn the sequence diagram later. But the behavioral diagram, what does that mean? It describes the behavior of a system. Well, that's funny why they call it behavioral if it describes the behavior, but that's what they decided. That was a joke. Okay. So suppose we have to create an account. I have to ask myself, what are the actions the system must perform to realize this? Activity diagram is a diagram that shows the actions that must be performed. And here we have that example that we just showed you in a diagram, which was much faster. Notice how the diagram was much easier to understand than this. This is just words. Enter username, the mail checks the user whether it exists. If it already exists, go back to 1. Enter password, mail server checks if the password, its strength of the password. If the strength of the password is weak, then go back to step 4. The mail server sends confirmation. In other words, this is words. The diagram actually is more clear. Okay. So we call this a workflow, these steps. And again, we're asking, what is an activity diagram? Shows the workflow. Okay. So the activity diagram represents the workflow. And you're going to replace the text with symbols. And here are the symbols. So this is the initial node, it's just a black circle, and there's a final node like this, which is like a bullseye. There's actually another node that's interesting that's not here yet, we'll learn later, which is also a circle with an X in it. But we'll learn that later, it comes up. Here, activity, he calls it an activity, I call it, well, that's why it's called an activity diagram, because it's called an activity. But it can also, but let's say in flowchart, it's called a process. It's the same thing. Here we call this diamond, we call it decision node. And you could actually have 3 decisions apparently. So it's not a simple if, it would be like if else, right? If this, then it could be, you could have 3 decisions here. And you also have a merge node where, what does that mean? That means that like after you did different things, there's different reasons why you would come to the same conclusion. You don't usually have, like, you could say, well, just have like many arrows pointing to this activity. You could do that also, but sometimes that's messy. So you have them come with different arrows that want to come to this activity, you have them come to a merge node. Then we have swim lanes, we'll talk about that later, and these we'll talk about later. This is it, we'll talk about now. Control flow, it's called a flow line, and it's shows how control passes from one process to the next, which is what is sort of obvious from the picture. Here we're just saying what they are again. And here we're saying it's a decision. It's also called a guard. There's a concept, we're not going to really get into it in this course, but there's a concept called a guard expression. And a guard is kind of like an if. Just another way of saying if. Sometimes we call it a guard. But it's not exactly the same, but for now, let's say it's exactly the same. Okay, so this is there's a decision prior to moving on to the next activity. So that's the decision. If this is such and such, then do that. Otherwise, do the other thing. Okay, so that's, and here is an opportunity to learn French, because the slide is in French. Too bad well, Karen is not here. Karen. Is there a rhombus? If there's an rhombus, there's a credit. Here it calls it a rhombus. You can call it a diamond, you can call it a rhombus. After receiving the video, so this says receive video command. I guess it means receive like the command from the terminal, from the video monitor, I think that's what it means. And then is the command valid? Then do some pursue other, see, look, it's English. Pursue other some other activity. And this is if the command is command non valide, command non valide, then you refuser la command, refuse the command. It's just English. Okay. Notice that in addition to writing the question on or near the diamond, we write it on the arrow. See, you could also write the question actually in this diamond or next to it. And then we also, in the previous examples, we didn't have both. And a lot of times they put it in braces or brackets. They put what the arrow means is the bracket, and this is what the question was. Because I guess theoretically you could have 3 things coming out. So the question could be a question, and then yes, no, maybe. I don't know. So it could be unsure or whatever. There could be some other answer. It could be not a yes, no question. Is it 1? Is it 2? Or is it 3? And then here I'd write, what is the number? And then 1, 2, 3, and then maybe invalid. I don't know. Okay. What did I say? Question. When is an order not valid? Oh, this is he's just asking why would a command not be valid? Maybe an order, you order, the product is out of stock. I don't know why this is here exactly. The product is in the warehouse, but the quantity doesn't exist. the product that is listed twice or more, you've got the same in your order, you wrote bananas twice. The seller does not support the payment method, okay, whatever, these are possible things to think about when some purchase doesn't work. Example 2, go to the ATM, automatic teller machine. I wanted to withdraw 200 shekels, so I put in the PIN, I validate the PIN. Is it valid? I guess what's using this and this. I guess validating PIN might mean like, is it a letter? If we typed in ABC and the PIN has to be numbers. So maybe there's some validation that occurs. I mean, it's a little bit weird why there's 2 of these, because then if there would be validation, then it could be not valid, so it should go back. So it's kind of redundant. I think this is actually not the best example, because if the code is going in, this is the validation. This diamond is the validation. Is the code correct? If it's correct, then do something else. If it's not correct, then go back. And here you have twice go back, because we have first time, second time. And if in third time, we don't go back, we destroy the card. Right? Sometimes machines work like that. But if you make a mistake with your PIN enough times, it doesn't give you the card back. Happened to my father once. A long time ago. Okay, here was the example we saw of entering a password and creating an account. Now we're talking about swim lanes. Swim lanes can help us understand who performs the action, because you don't see like which class is doing this check. Remember, if it's object oriented, what class is doing the check over here? So swim lanes. So for example, I do like this. The user, I mean, if that's a class user, I don't know, or the user enters the name and the password, but the mail server itself checks the things. So these are called swim lanes, where we contort the graph. I had to do some extra lines here too. It sort of ruins the shape of the graph, but that's it. Swim lanes can be vertical or horizontal. Swim lanes are used to add modularity to the activity. That's a key line. Because in other words, now I know I have a module called user and a module called mail server. So they can add modularity. That's the idea of adding modularity. In order to better understand activity diagrams, the activities participating in it can be divided into categories that can be. In other words, we divide these categories. There's no set rules about what is a swim lane. What should we write here? It could be who performs the action, like we saw, the user or the server. It could be actions before and after a certain activity. I don't know what that means. Step by step. I don't know what that means. Each category is named by a separate swim lane. I would say it could be the performer of the action in a module sense, like what module does it, but it could also be in the class sense. What class does it? That's what I would say, not this. I don't know what this means. Step by step actions. Okay. Rules of the start node, end node. So look at this. What about a function like this? Is this legal in C++ or Java? You pay attention, Eliana? Mm-hmm. Really? Yeah. Oh, is this legal? Do some code, return. Do some code, return. No. What? No. Well, it could be legal. No, it could be legal. When would it be legal? Depends what this code is. What is?
Oh yeah, it depends on the code. If it's
what, for example?
If statement.
Exactly. If it's an if statement, if it's if blah blah blah, if X, then do all these things to return this. Else, do all these things to return that. So you have 2 returns. How do you draw that in a diagram? So, oh, well, we'll explain that in a minute. But first, we're going to explain. I don't know why they did it like that. That's gonna. Here, I'll show you the answer to that. The answer to that is down here. See, if well, let's not say if, but this is 2 activities in parallel. But the point is, you actually, no, I take it back. I take it back. Let's stay over here. You could do something like this. Then what do you have? You'll have multiple end nodes. What is the end node? Bullseye, right? A circle with a circle in it. A black circle with a white circle with another circle around it. So you'll have 2 bullseyes, and that's it. Okay. Activity or action means do something. Oh, that's correct. Correct definition. is recommended that an activity is named with a verb, for example, receive, fill. In other words, in these boxes here, enter, or enter is the most primitive type of thing you could possibly say, but you could, calculate, salary, right? Maybe that could be a process. Of course, the process calculating salary could have lots of ifs in it, in which case it could be shown what is the process. The process is usually the most basic kind of thing you can imagine, like C in or C out, or A equals B, I equals I plus, I plus plus. That's an action. You could have several actions here. You can actually write code in the lines. It doesn't have to be words. It can be, if you're doing a loop, I plus plus could be could be a circle. Or you could have two lines. You have I plus plus, J minus minus. And that could be in the what do you call it, capsule shape. So you have actions and you have I don't know why there's a decision nodes written there, but arrows are called transition arrows. Okay, that's another name for them. And then there's a fork. What is this? There is no limit on the number of transactions entering an operation or number of transactions leaving the same operation. So I could do like this or even more. Of course, what does it mean? Is new activity 5 and new activity 6 and 3, are they done in parallel? Do I have to wait for all of these activities before I do this, or does any one of these that comes to here, then he does all of these? It's not very clear what is going on. Does he do all these activities and do they happen in parallel or sequentially? Maybe first I do one and like it's not. I mean, it looks kind of parallel, right? It looks kind of parallel. The exit transitions are activated implicitly at the end of the activity. In other words, at the end of the activity, I leave. And which do I leave? I do all of them. Once the action recevoir command BDO is finished, then I go to new activity. That's this one. Then I go to new activity 3 and 6 and 5. The 3 actions, 3, 6, and 5 are activated. But the 3 actions do not operate simultaneously, and we do not know the order. In other words, they're not simultaneous. They're one after the other, sequential, but we don't know the order. So therefore, don't do this. Better to use this synchronization type structure. To avoid confusion, either 3 activities simultaneous, sequential, or conditional. Well, it can't be really conditional, then I'd have to have a diamond. Use synchronization bars. The synchronization bar is a thick vertical or horizontal line, are used to indicate activities that start together as well as to indicate they end together. When you want to indicate activities that start together, you write this one. When you want to say they end together, you write like this. So that means they end together in the sense that I won't go on to this arrow until all 3 of these have been finished. It's called a join in programming. I join, these 3 activities have to all finish, and only then will I continue. And this means when I do this, all 3 of these actions happen simultaneously, not sequentially. How would I show sequentially?
Like an action arrow, another action.
Exactly, I just do. If I want 2 to 3 to happen first, so this will go to 3, and from 3 I'll go to 6, and from 6 I'll go to 5. And then I won't have these 3 arrows coming in. So this should never really be done. Okay, but the former is okay because you could have different branches of how you got there. But I wouldn't, if I had different branches of how I got there, then I wouldn't use this one. Right? This one that I'm covering here. This one wouldn't be for different ifs. Because if it's 1, then do this, and if it's 2, then do that, and they both come to the same thing, well, I can't wait for both of them because only one of them will happen. This means that all of them have, this one implies that these 3 were happening in parallel. So therefore, it only really happens after you did something like this. You have to first generate parallel actions. In other words, a thread or a fork, and then you can wait for those parallel actions to conclude. But you can't wait for you can't join non-parallel actions. We use rounded solid rectangular bar line, rounded solid, I don't like rounded, but anyway, I guess to represent fork notation. Okay, we use fork notation when both activities get executed concurrently, and no decision is made before splitting into the fork. Both parts need to be executed in the case of a fork. Okay, so here, if I do like this, then this means that these are happening simultaneously, and this is better. What does it say? We'll start at the same time only after recevoir command video finishes. Okay, serial execution, and if I want serial, like I said, I'll just do it in one after the other. Fork execution with a condition. What if I want, so what does this say? New activity, if the number is positive, then do these two things. If the number is negative, then do this thing. You see that doesn't matter horizontal or vertical. Okay, graphical symbol join. So the join, we already said, is have to support concurrent activities converting into one. They have to already be concurrent. For join notation to have two or more incoming edges and one output. In join, the black bar plays the role of a policeman, not moving to the next operation unless all the operations before the black bar have been completed. And activity diagram shows the sequential operations and also the parallel operations. So here you go, activity. Then when this activity finishes, do these two things in concert, and then when they finish, do this new activity. A fork node is used to split a single incoming flow into multiple concurrent flows. It is represented by a straight thick line. We said that a million times. A join node joins multiple concurrent flows back. We said already. A fork and join mode used together are often referred to as synchronization. This is called synchronization because I synchronize these guys until I continue on. Benefits of activity diagrams. They present a number of benefits to consider using activity diagram. 2. Demonstrate the logic of an algorithm. Well, that's what I did in 10th grade, right? In other words, that's basically what we used to call a flowchart. You can show how to do a loop or how to do a loop within a loop. Describe the steps performed in a UML use case. If you have a use case, you can take those steps of the use case and turn it into an activity diagram. Illustrate business process or workflow between users in the system. But I can show like the interaction of a user and an ATM machine. Simplify and improve any process by clarifying complicated use cases. Right, but just like we said before, we can deal with use cases, but it can help us make something complicated more visual and therefore easier to understand. Model software elements such as methods, functions, operations, right? You can show the actual behavior of a function. You could also add a note with this little note symbol. Allows the diagram creator to collaborate or collaborator to communicate additional messages that don't fit within the diagram itself for added clarity. Flow final state. When you want to express the end of a certain flow, you use the end mark of the circle like this with an X. In other words, the flow ended, but the program didn't end. When would you do that? If the program didn't end, the flow ended, then what does that imply? That the program is still continuing in some other place. Well, if it's still continuing in some other place, you must have done a fork. You must have had a fork. So in other words, you could have a fork, you could come to a fork, and then one will continue and then go to an X. And the other one will continue and go to a bullseye. Right? This flow has ended, and not the entire process. If all the different flows have come to an end, then obviously the process is an end. Represented by the end of the specific process flow. The symbol shouldn't represent the end of all flows in an activity. At that instance, you would use the end symbol, which is the bullseye. The flow final symbol should be placed at the end of the process in a single activity flow. Okay, so here you go. See, we had a fork, and now there's no final program because we don't know which one ends first. So we can't say that we could have that though. We could have a final one here, but that would imply something different. That would imply that when this flow finishes, whether or not this flow finished, end the program. Right? If I had a bullseye over here, then that would mean when this flow finishes, end the program. regardless of the state of this one. But by doing it with two X's like that, that means that the program will continue running until both of them have finished. Here we added the other one, and that means, like I said, now if this one finishes, then the other two will end in the middle. Example, here you go, an example, here you have a worker, and he's inherited by all the different kinds of workers. And then this, we've seen this before, this is a use case diagram. And now here we have an activity diagram, not the most beautiful, but it works. What is this saying? Present your type of membership, choose your type of membership. Question, are you paying in cash, a check, or credit card? And then in all of those cases, you go to the same thing, and you go to this unifying, remember this is called unifying. If there's also a possibility that he would be he's not gonna pay, he doesn't have any of those ones, he wants to pay with Bitcoin, and therefore you go back to here. And you don't pay, because we don't take Bitcoin. But then if he did pay, this is very weird what he's doing, because he's using this diamond in two reasons. Is also a joining diamond, but a joining diamond is not supposed to have an if. I don't think that's right. Let's see. Didn't we say that? Didn't we actually explicitly say that? Or maybe we didn't. Maybe I said that. That's a decision diamond. Merge node. Okay, well, I'll check that out. That's an interesting question. And then he goes into the park. Oh, I don't know. He puts in his details, and he creates a membership. Here's where he chooses. He chooses which kind of membership he wants, and then he pays. Fine. Okay. Not the greatest example. Activity diagram. I would prefer an activity diagram of like mamish, like build a bubble sort. You know what I mean? That would show you logic. It's a process. Bubble sort is a process. There's no, I mean, there's ifs in there, but it's a process. Right, it's a process. Okay. Activity diagram, checking facilities. Whatever, you get the idea. Comes in, you check something. Yeah, again, he has an if. What does it say? It says, getting a list of all the equipment to be checked. And then, are there equipment to be checked? Go here. Are there no? So there's no equipment to be checked. So write a report that shows that we didn't do anything, or that we did whatever we did. Of course, in this case, we didn't do anything. Now, now here I have to report that something is broken and what I'm fixing. Is it working or not working? If it's working, does it fulfill, I'm checking if it fulfills the standards of the city's requirements for these facilities. And then if it fulfills the standards, then approve it. And then go back and check if there's more stuff to be checked, and then keep going. But if it's not approved, then report that it's not approved and still go back and check. And if the particular one that I came to was not active, in other words, it was like a disabled piece, then remove it from the list and don't do anything. Okay, whatever. So that's your process of behavior, what's going on. And here's that same example, I think, right? No, there's another example where you see swim lanes, and here, what is this? This is a booking example of swim lanes. So this says, you're choosing the date and you're choosing the type and amount of guests, I guess adults and children, slaves, free men, I don't know what the kind of types of people they have are. Anyway. Kviat tarif, you determine the date. And then you do both of those things, and you do them in parallel because. I guess I don't care about the order, it's not like the order is dependent between them. So it doesn't have to be done in parallel, it could be done sequentially, but I'm writing it in parallel to indicate that. I don't care about the order, there's no particular order here, it's not like a bubble sort where the order would probably matter. That I do things in, here it doesn't really matter, but I can't go on until I have finished both of them, so I have this. Join here. And then I go to this triangle, it's not triangle, a diamond. And I say. If it's panui or not panui, is it available or not available? If it's not available, then I change the date. And if it is available, then I go and I say. Is it a existing package? Or is it a you designed package? A package like a vacation plan that you designed, you chose the hotel, you chose, you can get a pre-packaged deal where it's the flight and the hotel and the car from the airport to the hotel, all arranged. That would be this case, and this would be a case where it's a self-managed trip. So if it's prearranged, then show him, if he wants prearranged, then show him the possible choices. Let him choose a choice, and then get the money. But if it's he's choosing it, then he should choose where he wants to go and what other services he wants, and then he should calculate the cost. And here, if he went to paying, he should go and pay and be finished. And here, if he did it himself, then he's going back. And I don't know why that is. Why should he go back? And he's gonna change it, but it's just kind of finished. I don't know, because I would have an arrow to here, to out to here, let him pay. Anyway, the main point is it shows you the different stages in the program. This is the first stage, defining what he wants to do. Second stage is what the actual contents, not the type. This is the type, but this is the actual contents. And third stage is paying for it. And these are different sections of the program, and that's what the swim lanes are for. Okay, that's the end of the lecture on activity diagrams. Now you're experts in activity diagrams, except for that one question which we have to investigate, which is, what was the question? Can you have a node that is simultaneously a decision node and a merge node? Let's check that out. Let's just go to Google and see what Google says. Thank you. In activity diagram, can a merge node also serve as a decision node? Yes. Fine. Kind of weird. But that's in umldiagrams.org, they should know. Right? Shouldn't they know? Merge node. Okay, let's go back to where we were. Slideshow, the current slide. Okay, now we're on classes. Dependency. You know what a class is, right? You probably learned class diagrams. right? Have you done class diagrams in Mavo, in the introductory class?
Yeah, so
You did something, so we'll do a little bit more. Truth is that only a little bit more.
I don't think we learned it, we just saw it.
I just
We
saw
had
it.
to like figure it out ourselves. We
It-
didn't go into depth about like what it all means really.
Okay, so there's not too much to it, but the truth is. Well, let me explain something that's not written here in the slides. There's above the line and below the line. Why is there a line here? You know why there's a line here?
It inherits.
No, the line here, above the line are the attributes and below the line are the methods. You know those terms? Attributes is like the variables in the thing, the data. And methods are the functions. They decided to call them methods instead of functions. But whatever, okay. So this is where you write, like, if it's a class like dog, here you'd write, number of feet. Dogs have only 3 feet. Here you'd write like, what is it? Type, breed, you'd write age, all the things that I think, and here you'd write like wag your tail, or walk, or eat, or shoe of owner. Those would be the methods for dog. This arrow here with a dotted line is called dependency. Dependency is the most basic, is the most weak relationship between classes. Meaning, dependency is when one class uses another class in some way. There are 2 examples where we have simple dependency. Class A has at least one method with at least one parameter of type B. So one of its methods has a parameter, which is the other class. So it's dependent on the other class in some way. It has some dependency because it needs the other class to run this function. If the other class would cease to exist, so there wouldn't be that class in the system, then this function wouldn't work. The class would work, but it would always not work. It would only not work when I tried to use that function, but the other thing would still work. Or class B instantiates at least one object in at least one method. Again, it's in a function. So when it's in a function, it's only dependency. Dependency is the lowest. In both cases, A is dependent on B. If the definition of B is removed from the source code, A will break. If B's behavior changes, A might break, right? If B, maybe I'm using B because I want a certain behavior of it, and that behavior changes, well, then I can't use it. Okay. So how would you implement this in Java? Do you know Java? Yeah, kind of. It doesn't really matter. But here you have a class B and a class A. And we have a method called method, which has as a parameter, it has a B. And here is another method which doesn't have any parameters, but it has an object of B. And over here, we're just showing you that I could create an A, create a B, and then run on A the method 1, where it needed as a parameter a B. So I gave it a B. See, he didn't actually declare an instance. Here he declared an instance. Okay. This is not right. If you do something like this, where you actually in the class make a B, then that's not simple dependency. I notice I'm calling it simple dependency because the truth is that the next thing we're about to learn is also a kind of dependency, but we give it a special name. And we call it association. And then the arrow becomes dark. One-way unidirectional association relationship. Above, class A maintains a unidirectional association relationship with B. It's also called a navigation. Association is a tighter connection between the 2 classes. Therefore, replace the dotted line with a solid line. Class A contains an attribute which is a pointer or handle to an object of type B. But B does not contain any attribute A. In other words, B does not know that A exists. But he has a point, contains a pointer, and you do it like this. In the actual class, there is actually now an instance of B. And there might be a function to return it if it's private. Fine. Then there's a 2-way relationship, or a bidirectional association, which is a solid line. Now, I don't know why they call the first one a dependency and the second one association. It should be the other way around, probably. Because in English, association is less than dependent. But this is considered a stronger one. Because here, if B stops existing, then I can't even create my class. Hello? כן, אתה יכול להשאיר את זה למטה בדירה אחת? כן, יש מישהו שם, אני חושב. בכל הכניסה, על יד המדרגות יש... Okay. Any questions, first of all? No, it's all very clear. So this is called a two-way association. Oh. Okay, two-way associative relationship communicated by a solid line. So in this case, class A contains an attribute that is a pointer to an object. Well, in Java, we don't have pointers, we just have instances, but same thing. An instance of, or a pointer to an object of type B. And B has only a type A. They're each using each other. I mean, that could be reasonable. For example, you could have a class called two.Zahoot number, which has got lots of things in it, maybe not just when the two.Zahoot was given to the person, when the two.Zahoot was created, what it's, how many times it's been referenced, I don't know. And then maybe a person, and maybe person has a two.Zahoot number, and a two.Zahoot number has a person. Or maybe it's a bad example. Maybe a teacher has a class, and a class has a teacher, right? And every class has a pointer to who the teacher is, and every teacher has a pointer to every class he teaches. So there's a lot of times actually that you would have such a thing of a bidirectional associative relationship. So how do we do that? Here you see class B as an object of type A, and class A has an object of type B. Here, student class and instructor class. So every student has an instructor, every instructor has a student, has many students. The doctor has a patient has a doctor. Okay. Student class, university class. Every student has a university, and every university has students, has many students. I want to come up with a one-to-one. These are one-to-many examples. That's probably more common, but I was trying to think of a one-to-one, where what did I say? I said student class, yeah. But okay, that's not one-to-one. But let's say two.Zahoot and person would be one-to-one. Okay. Aggregation and composition, unfortunately, is not in the material this year. I don't know what it means. It's taught in the second semester. I guess there's no other course, as far as I know, that teaches this, but is there? I don't think so. But it's not in the material, even though I would put it in the material. Multiplicity degree. So you can say the degree of how many they have. For example, if I say that a student has or a teacher has many students, I want to show that there's many. He has many. So they indicate how many. And we have a picture, you could do 20, 0 to 1, 0 to infinity. 0 is kind of weird because you could have none. Any number. And we don't have a picture of it. It's a pity that it doesn't have a picture of it. But basically what you would do is you would write like a 0 here and a 1 there, or a 0 to 1 over here. You'd write on the line, kind of over here. Inheritance. Inheritance with a triangle. See, we had a triangle before for association that was one directional. But this triangle has a line through the middle and no back. So now we change that around and we use for inheritance what you could call a full head, a full arrowhead. And this means who is inheriting from who? A little bit confusing. What does the arrow mean? So actually, you might think it means that like A is the source and he is the inheritor, but it's the opposite. B2 is actually the parent class. He's dog. And A2 would be poodle. The general concept is always pointed to. So exactly like we read here, B2 is independent. He doesn't have anybody. But A2 is it extends. How do you do that in C++? I forgot the word in C++. You also use it extend. Use inherits, no?
Yeah.
No?
Okay.
You forget?
Yeah,
Inherits?
yeah.
Yeah, I think so. So in C++ we use the word inherits, but in Java we use the word extend. Okay, so B2 is a superclass. So in this picture, B2 is a superclass. He is what we generally call a dog, and this would be poodle. And the subclass is A2. Just remember that the inheritance symbol creates a line from the subclass towards the upper class with a clear triangle on the top. Okay. Here you go. Bank account, two different kinds of bank accounts, savings account, credit card account. These are also called, this is a good line, specialization. Because this is a bank account, but it's a specialized bank account. And this is a bank account, but it's specialized. So, and also, if you look upward, it's called a generalization. Because a savings account is generalized to be a general account. Right? This is a general account, or a bank account is more general, so that's a generalization. So when you go down, it's specialization. When you go up, it's generalization. A connection called realization. So here you've got a combo of these things. Now we got the full arrowhead, but a dotted line, and that means realization, which is an interface in Java. In C++ it's called a virtual class, where you have B, and B is what makes B virtual, or it needs to be implemented. Do you remember? Shana Aleph?
There's at least one method that isn't.
Yes, there's at least one method that is not implemented. It's just written the name of it, but the child has to implement it, and therefore you can't create an instance of that class until there's an implementation. And therefore, it's just an interface. It's not really a existing class. It just interface. It just shows you what does it mean an interface? Why is it called an interface? Because it shows you how the interface should be. It shows you how I want you to interface with people, but exactly how to implement that, I leave it to the inheritor to do. So it's kind of like inheriting, but it's BA3 gets everything from B3, but he'll have to delineate, implement the functions. And it's called realization. In general, in the abstract philosophy of programming, it's called realization. Okay. An example of realization, we have an interface printable, and you see here it has print, which is undefined. And then A6 implements printable, and we got to define print as printable. And now in the main, I can create an object of this type and call print. Interface implements, this is the relationship interface, the class implements the interface. Printable is implemented by A6. Realizations of the degree of plurality in the Java language. Wait a second. Yeah, okay. We didn't write the degree of realization of the degree of plurality. For example, here we have class A, which uses class B, and it makes an array of it, but it's undefined, right? Now, this is showing you how you would do like star, one dot star, like on one or more. So I have to put some number here. So I have a function called get index, or get b1 and an index, and then no, that would be giving me the index. But here, this is problematic, right? This pointer, you make a pointer, but you don't have to be in any size. You'd have to give it a size later on. In the constructor function. Does Java have constructor functions? Yeah, I guess it must. Okay. Disadvantages. It doesn't like this, he's saying. Dealing with arrays is complicated. I don't know why this is here. Exactly, it's not really our topic about exactly how. I'm trying to show how to implement, but now this, I don't know why is to discuss why an array is not good. We have to reallocate the array every time a new item is added to the array. Right, that's why we learned linked lists, right? Remember that? We learned linked lists so that we wouldn't have that problem. We need to check the range of indexes before you can access the array. Maybe you go beyond the end of the array. The get b1 method is not well written. You'd get a runtime error because if I just let him give me any index and I'll just go anywhere in the array, I could go outside of the bounds. So this function is too simple, not well written, is an understatement. All right, that's it. that is a lecture for today. Stop recording.